Hello guys, welcome to another programming stream today. We're going to be working on a new project, or actually no, the same project we're going to be working on Bitwise operators today, and it's going to be pretty good. It's pretty simple stuff. Well, actually not really. It fucking hurts my brain sometimes. I'm very happy with my background, it's very amazing. But let's continue. So yesterday we were working on fish bitwise.d, our program, well, our library of different bit tools. For example, we have set bit write bin, which just takes a formatted write line, does all that. You'll notice the imports are inside of the functions. I like to do that now. Because obviously, you might not always need a write bin, but anytime you call write bin, you might be actually importing that in there, which I kind of don't like. That might increase file sizes slightly and increase compile time. I feel like it could do either of those two things, or both. But anyway, continuing on. That's the only import, actually. It's the only... I haven't tested yet, though. So it might need some other imports, but hopefully not. Me setting up my I'd be like, alright guys, let's go to the desktop. Actually, I like to do it like this now. Because then you have your file manager on the other side and you'd be like, oh yes. So I've been watching a lot of videos and stuff lately, like seminars or stuff on delaying to learn more about how to use it and stuff. LS... What are we looking at? LSFT runtime? Why does it have DUB? What about, so I learned some things from those, right? From the specific ones I watched, I was like, there's quite a few things I didn't really think of doing and stuff like that I learned from those. It was pretty good. A lot of things that you don't consider are learned from watching other people do it. Like, for example, the importing stuff inside of your function, learn that from there. The other thing is like when you want to... I don't know what some of these are. I'm trying to think of this. Where did I put it at, actually? Oh, probably fish common. Here we go. Fish 64 is going to be the actual emulator we're going to build off of this, but we'll do that in a bit. The emulator idea is to create my own emulator for some architecture that doesn't exist, that uses that. I mean, and then build stuff on top of that. But I think that's a crazy idea. I don't really know much about such a thing. Just kind of simulate stuff, I think, will be the idea. But probably just could be a lot of big switches and stuff. Let's see. So we're going to create segment bin, because I want to be able to read, like, the first 4 bits, or skip the first 4 bits and read the next 4 bits, or read by bytes. I guess read half byte, read byte, stuff like that. The idea will be that we have a length that we want to read, or 2 endpoints, basically. We say, I want to read this, and then it takes a slice of that. But it doesn't actually take a slice, because I don't want to have to waste memory on such a thing as an array. This is kind of, like, I have this, and you'll notice we're using ulong now. So let's go ahead and dmd Usually I time it, but I just DMD fish bitwise dot d, get the errors. Yeah, for now, just comment both of these lines. Easy. All right. Ah, it's not callable by those because it wants a U-byte. All right, perfect. So where is that? Here. Input. Cast. U-byte. I'm pretty sure there's a better way to do this, like declaring it as a constant, or having an array of these numbers, just on hand or something like that. But that would be shitty as well. What do you mean it's not? Oh, did I not save it in here? Get bit input I. That's U-long. That's I mean, that should be fine. Hold on, I've done something clearly wrong. Maybe I could just declare it as U-byte instead of trying to cast it. It wants an int. There's only two states it can be, which is true or false. So we could just do a boolean instead. Say bool, and then cast it to true or false. What is it saying? Set bit or get bit? Get bit. So why is it saying get bit is not callable by type? And one. It's not callable using types. Is there like a cast in it? Hold on, where is this at? 31. Input an I. So it's not callable by types int? Oh. U-byte? I mean, I'm sure that'll be fine. Never mind. We don't need to do anything stupid. Alright. Segment bin. Ah, that's not even done yet. But anyway, set bit. I also added the switches and stuff already. So we already are using a switch function of some kind. Not a real switch function, but we're using if-then statements to do a lot of stuff right now. So you can see switch is or set bit is a statement that takes a boolean, or a function that takes a boolean to determine what to perform on the given object or integer. So you would do your input number, a boolean, which is in this case true, and then the position. For example, if I set this to 2 and set this to false, you'll see that it does the opposite. We'll actually set this to like 7 or F or something. 7. And you'll see that it changed the 1 here. So that's the purpose of this tool, of that tool. It kind of just changes a bit. Kind of useful stuff with that. This is going to be padded to 64. The way this works is that this is a formatted write line, and this is the identifier for binary, and here's a padding of zeros in it. So it's 64 zeros now. So DMD and then time, which makes it kind of hard to read, but you can kind of, I want to split every 4 zeros, I guess. I don't know how to do that, but I mean, that'd look way better than just having raw binary lines in here. Obviously, I think I can then write these out, I think, potentially by piping them. I don't know yet. Well, yeah, I could definitely pipe them as an output into a file or something. That's worth figuring out later. But we want to work on the new function, which is going to be right here. This function. Obviously, want to make this into getting, like, what? Taking a, or we want to find the first 4, right? Yeah, it was like finding a specific value. Oh, wait, I don't need to do that. I just realized we need to leave this as is. Finding those values. That should be our focus. But it's gonna be a minute. Let's see. So this creates when we do get bit. Let's just go over this real quick. To get a bit, we take an input and a position, and so the input number, that's obviously the one we're performing on, and it takes an AND operator to determine if that position is 1, or actually, yeah, if that position is true, then bin will return as a value. Why isn't this a U byte? Because that wouldn't make sense, would it? Because these don't need to be long. They can be a U byte, I think. Because that's just one number. I mean, actually, nah, you leave those as longs. They need to be a U long. That way it doesn't change what we're working on, and then we end up with a U byte when we need to have a U long. That's why it's like that. So this is from, it creates a mask basically, where you shift it by position and then it checks it by 1. So like, let me get out this so I can kind of draw out what I mean. It's kind of like if we do, for example, if we have the number like 0, 0, 0, 1, 1, put a 1 here. Like if we have this number here, we just take this and we just move it all the way over here, and then it becomes like 0, 0, 0, 0, 0, 1. And we're like checking, we're basically shifting it that way because I mean, this looks terrible, but we're basically shifting it this way, and then checking it with the AND 1. And if it returns true, which it will because it's a 1 and a 1. Like if you said your position is this number here, so like let's say position equals 1, 2, 3, 4, 5, 6. So position equals 6. We shifted it over 6. So then we check it against 1, and then boom. So I think what you could do is, let's say you have let's say you have like what's it called? The number, oh, like 0 or 1, 0, 1, 1, 1. Obviously, we need to get rid of this number And if we want to check this number in the middle, that's a problem. And then we have a number here. You could just say, get rid of this number and get rid of that side. However, we could also just say, we know the position is, or actually, if we have an actual byte, we want to check that first one. This would be the easiest one to actually model. You would take these 4 and shift them over. So it becomes 1, 1, 1, 1. And then you check it in the same pattern, I suppose. And 1. The problem is that this is 1, 1, 1, and we want to find that. We want to find what we're checking it against versus that. Like if we had 1, 0, 1, 1, and we wanted to check against that, obviously that's going to return false. So this needs to be a variable, I think. This one should, this is just a number inside the original integer. This will have to be a variable because we'll be checking, it can change. We can check this number and say if it's not that, and that's useful. So that this is an if statement, essentially. So that would be like if. This is literally me creating an if statement, almost. Or if function, or something like that. So we have that and that. That's crazy. I just not put 2 and 2 together, and that's what this is. Literally an if statement. Now there is some things that are concerning with this, which is that obviously we're going to need to make that a variable. But like I mentioned earlier, if we have larger numbers and shit like that, I think there will be issues. Like, yes, we only have 64 bits to work with, but 1, 1, 1, 1. Let's say we have this 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1. Why not? That's amazing. We want to check this one specifically. Now we have a variable amount of things to do. We have to push it right, I think. So we'll put it all the way right. Put it 0, 0, 1, which means we now have 1, 1, 1, and a bunch of zeros in front of it. So boom, 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 boom. These aren't going to be modeled at all. They won't even matter in the actual program. Now we need to move it the opposite way and be able to determine that and get rid of those zeros. And the ones. I mean, the zeros don't matter. They're nothing. Because when we check it against our original variable, which we're checking against, which is like, bro, I cannot draw ampersand. What am I doing? Like that, and like, what was it? 0x, don't do it in hex, just put 4. Like, we want to check this against this. So to do that, it's like, we now need to move it back that way, which is a problem because obviously if we're checking this one, that original one, like what if we want to check this one? Well, now we still have those. So the first part, either we need to shift it this way and then shift it that way, or we could try and shift it the other way. And from the start, like shift it left from the start so it gets rid of those front numbers if it's in the middle. So we need to be able to determine the position of the number and where there is integers in front of it. Although there is ways to do this better. All right, so here we have this number. We're gonna check this one now. Move it this way, which gets rid of all of that, and then we just have 1, 1, 0, and 0, 1, 1, 0, 1, 0, 1. But like trying to move that and get rid of the zeros, like that's the easiest way to get rid of zeros. Although we could try other methods, like for example, you can OR things. There's like a lot of ways to do shit. XOR, for example, exists. Obviously, we're looking for one specific set of binary, which makes it kind of like we're looking for that. But then we have this still. And I mean, this is in the middle of 16, right? We move it all the way here. Then we try to move it back, and it has to be moved back 1. That's a determinable pattern. It will always be moved forward 1 or 2, and then back 1, or the other way where it gets... I mean, that's something we could use, potentially. Although, I don't really know if that's the best way of doing it. I mean, we could just look for answers online, I think. How to use Bitwise operators to read a byte delay. Yeah, I'm sure somebody's come up with this. C? Use a logic gate is better. Yeah, I'm sure. For example, to check if the third byte is byte B set. Oh, these are like those. Create a mask using the left shift. Create a mask with 1 desired bit position. Well, yeah, it's to check bits, not to check bytes. Or what? Yeah, but we've done this. Oh, this might be what we're looking for. To extract multiple bits, a bit field from a byte, you can combine right shift and bitwise operators. Well, actually, wouldn't we could just do it in like repeated sequence? Moves the desired bits to the least significant positions, positions 0 to N1. We want bits at indices 2, 3, 4, which are 1, 1, and 0. So you would do int position and int for width. And then that's actually not that bad to implement. Yeah, so I figured there would be some kind of interesting thing like this. So the starting position and the width is like the endpoint. I think the width... Yeah, so they just create 2 masks. I figured that was kind of part of it. Alright, so let's take that and apply that somehow. Looks like it is not bad. We need a position, a width, and our number. So they have that as well. Oh wait, we don't need an int. Necessarily. We need a... What is it? Usually, well... Yeah, ubyte should cover all 64 bits. Yeah. Use ubyte for this. Ubyte. And then... another ubyte after that. Ubyte for position. Ubyte for width. And then what we're going to do is exactly what that does. So here it creates an extracted U byte, but we're just gonna do a U long at the end. Technically, you can just return. No. So we would do U long return or output equals the equation. So that position creates a mask, and that to that -1. I don't know why they do the -1, but we'll go ahead and start on that. So mask from, what was it? The position to the thing? From our original number to the position, and then the other thing. From our input to position. So that shifts it to the right, and then shifts it back to the left, but leaves it -1 at the end. So like it shifts it to the left, but also gives a -1 in there. Width, oh, shifts it, and then that subtracts 1. Or wait, the width is actually included in that second portion. So then what it does is position, or why am I doing position? It's just pose for position. And then shift it, and then width, shift it left, or shift width left by position? Or is it just shifting position left by width and then subtracting 1 at the same time? Well, that, and then does that by and. Oh wait, so like it does this equation right here, right? It does this part. Shifts input to the position, which means shifting left to position. Ands it by this equation, which basically checks if they're the same. So if they're the same, it will return true or false. So this statement here, or this expression says, position is shifted right by width -1. So we can model this out again. Let's do that. Let's just draw it out, kind of. I think drawing things is easier to understand than anything. So we create a new image. All right, so we have a number, right? We have 0, 1, 1, 0, 1, 0. Actually, that wouldn't be valid. Just get rid of that, and then 1, lol, lol. That's where we have that's our number, lol, lol. And then, so the first step was we shift it right by position. Or, yeah, shift right by position, correct? Okay, so let's say our data is this, and our position was, we want to check this section, so we shifted it all right. Boom. But it only moves that one, since that's what that would mean, is data moves right by position. Boom. So that just moves the 1 to there, but there's still the 1 and the other 0 up here. And so now the AND portion kind of fixes this. Technically, this would all be a 1, 0, 1. This wouldn't be the case. So it would be a 1, 0, 1. Why wouldn't that be? Why would you AND it by 1? Oh, because that's the check. Ah, that's the check. That makes sense. All right. I mean, I figured it out now. I don't think I need more help on that. Yeah, so that's the check. And then it returns output in this function. Yes. And then also, I've been trying to make these look better, so trying to get in the habit of putting those, spacing them out. Since that is technically the proper syntaxing is, well, you can do it this way, you should space it out. Wherever there's one of those. Technically, you're supposed to space out the function brackets as well, the parameters for functions too, but I am not. I'm not doing such a thing. All right, let's go ahead and all right, it worked, but we want to get the values. All right, so what we're gonna do, we're gonna take, what was it, segment bin? So we take our input, we take the numbers we want to specify for it to check. So the width is not 7. Let's say we have technically the technically these can be like super amazing numbers. These numbers are amazing. Yeah, amazing numbers. Bro, like I don't even know what I would do. Like 0xff now would be like barely any in that. I'd have to do like 0xffff. That is valid. But u long is a massive number, so what we're gonna do is we're gonna put in 0x0f, which is the number 15, but then we're gonna do a couple other things. First of all, we need to do a bunch of set bits, so that way the first numbers at the 64th position are like checkable. That's gonna be our first test, is checking at the 64th position. So for example, we have our u-long input, right? We're going to take that, we're going to put it into a set bin, or set bit. That white color is 0x0, or 0xFFF, yeah. Set bit. I mean, I don't really use hex for colors or anything. Well, you know, I guess if I did more GL stuff, I would have. It just takes an input and a position. Right, I forgot about this. But also, this one needs true or false. It's this one. So that one would be setting it to 1. This one sets it to 0. So if it has a false, then yeah, that's good. Input, false, 64. I think that should be fine. Although they do start at 0, so 63. And that should be good. So this one, we're gonna segment the bin at the 0x63. And we also are gonna set another bit at 0x62. Or what are we checking? The width of it was like 3. That's not how you write 63 in hexadecimal. I'm writing hex, but with regular decimal this point. Let's just do regular numbers for those. So that will be input in 63, and then I do like the 0x 0f here. That makes it really easy to read. But the rest of it does not need to be hex. So that's the set bit. And it also needs a set bit for the other one. What is this doing? Set bit return values discarded? Oh. Easy. Easy fix. Copy this. Paste that in there. Boom. And then we should do... The next one should be at like 61. Let's see if it returns... We'd expect like a 101 or some shit like that. 1010 is what we expect to see in this case. It starts at 63, and so at 63, the first thing we do is we go... You know what I can do is I can collapse these to make it really easy for me to find them later. That is a useful thing to have. That makes it readable without me having to change shit. I've never used that, actually. That's a new thing I've never used before. So yeah, we expect 1010 in this program, so what we should look at is then having the input let's see. I just want to make sure it works before I actually do it, and I'm thinking through the process right now. And then, so our input... I mean, the easiest way to figure it out if it works is just to figure it out. 1. Why does it return 1? Well, what happens to the first numbers in the equation? Oh god. So, what do? We're shifting things right way too much. For example, in these cases, those typically are just to the... that happens because it's shifting it by position to the left and then setting them as 1. Or comparing them to 1. Let's try 31 and 32. Or 33. Very interesting. Wow. Well, I mean, we should be setting the integer to the integer limit by sending the first part of the number to like a 1. So what is going on with set? Because that is not the expected behavior. Maybe it doesn't work well with such a long number, but... Or I'm giving it too much to handle in this U-byte for the position. Alright, so move it over to the position. Check if it's 1. And make it equal to its out. Make it equal. So in the actual check bit, you don't even set anything equal other than... actually, you do return a bin. Although it's kind of strange. I have to play with this more to understand what I'm actually messing with right now. So, I mean, I really don't understand why it's doing this. Let's try setting 12. Maybe it's that I'm not using hex for like once in my life. Or it's that I'm using the... Try those two numbers. Let's see if that works. Could be that we're setting it like in sequence, like we have got 2 in sequence. Try true. Bro, this is crazy. True. See if that works. Because that's supposed to unset numbers. Oh, wait. Yeah, it unsets numbers. False. So that will be the one that actually sets them to 1. Right, that works. Those are at the correct positions. I'm guessing it goes up to 31 for some reason. You'd expect a U-long to go to 64. That's kind of annoying. So at 31, it gets angry. 31, it starts to go, yeah, no, you can't do that. Maybe 30 is okay? We'll try 30 and 29 this time. And see what that even means exactly. Those are okay. So the length of U-long is confusing me. U-long, D-lang, size? 32-bit unsigned integer. Bro, I don't care about C#, bro. Yeah. Okay, well, why is my 64-bit number 31 bits in length? Not even 31 bits. It only goes up to 29. Like, what is this? Can only go to 29. I'm guessing it's just a problem with... maybe we should just go back to using regular ints. Ints were better. That's where it ends. That is the positions it ends at are those. If you do 31, it just breaks. Anything besides 30 and 29, you'd expect a 64-bit number to be able to handle that. Well, actually, what is the return on this? That's the real question. Is it returning an int instead of a U-long or something like that? Or is input becoming a U-long? Or is it considered an int in that equation? So it's returning an output. Or like, it's returning a U-long. I mean, what is going on there? That's the real question. Maybe we'll figure that out. We'll figure that out. It's just a bit of brain pain. Really didn't change anything and it just did that anyway. Oh. It's pretty fast too. I mean, we barely have anything going on, but that's gonna be good. I like that it's fast from the start. Hopefully it'll be fast at the end too if we know what we're doing. Let's try taking 30 then. Then do, since 29 is okay, then do 28. Just to see that this function works. Returns 1. But I guess it should just be 28. Then do that again. Yeah, that works. Starts at the last number, takes it all the way back perfectly. Gets rid of this extra string of ones at the beginning from the 15. So that's pretty good. The other part, the part that's not good, is the fact that ulong is not doing as expected. But it's ulong. Maybe we'll figure it out. What is a uint? Probably a 32-bit. I mean, it's 32-bit unsigned integer. We could use uints for this instead, maybe? And switch it to uint for everything, since it doesn't want to do 64 bits for whatever reason. I mean, that makes sense. We're going to change everything to uint now, guys. Starting here. This is amazing. Paste. I mean, I don't really mind. I'll have to rename it to Fish32 again, since that will be the system we've designed. I mean, that's not bad, because that means that I'll just be able to, if I make this in a Verilog system, I'll probably be able to make more like cores and shit. I wonder how that's going to work. Because I do plan on getting some Verilog, FPGA boards to experiment with. What was that? That was a bool, wasn't it? No. Okay. Boolean. We all like Boolean here. I'm sure there's a way to select them all. Like, maybe I can select them all. Yeah. I don't really want to select them all, since I don't know which ones are not meant to be that. Alright, so that makes a U-byte array of the number. That one's kind of like the one I don't even plan on using. I don't plan to use arrays for much, especially not creating an array of a number in U-byte. I feel like that one's probably going to get cut from the final design of this program, but apparently I fixed it well. Okay, and now we don't need to pad them out to 64. Zero 32B. Perfect. Nice. So if we go up 1 to 31, does that do what it's supposed to do, or does it fuck it up? What the hell? Oh yeah, so it copies from 28 forward. So if we were to go to... yeah, it's 4. So if 28's here, then 4 more is 32. That's actually perfect. This is exactly the type of things we need. So that finds them. So like if I had, for example, let's say I would have finds at the position, or what is in the position of here, like what's this stuff? We'll say 4 minus 28, so 24, and then 24 to 28, right? That should be the number we're looking for. Oh, also, that is 31. It only grabbed one number, though. That's because in 24 there's only... yeah. Oh, wait. But that's because it grabbed 28. But this should not be... I mean, I think it does start at 0. Yet again. So, like... just grab the 1 and 3 zeros. I think that's working, but I think this needs to be down to 27 instead of 28. Because that is not within the... that works perfectly. That's exactly what we're looking for. So yeah, that's good. Brilliant. So now what I can do with that is use that to check if statements inside of a case. Basically, create a switch or use it for case and switch. So we'll open up well, it was called fish 32. Now it's called fish 64. So engine is basically going to be a massive struct that contains all of the data about the system itself that we're designing off of these binary functions. And then from there, we'll figure out what we're going to do with it. But this, from what I understand, and from what other people have told me, basically, when you create like a emulator or like a system like that, all it is just a bunch of if-then statements. I figure I can do the same thing using switch. So if engine state equals this, which engine state is right here in the struct. I don't know if that should be a struct or what, but I think I'll try making it a struct. This creates the engine object or engine struct, and then this now can be like switch engine state if it equals that number. However, that's not necessarily what we're looking for. Well, actually, yeah, engine state. The real question is like, how do we initialize engine state? That's the real question. And that's why we made that function, the segments bin. So we're going to get rid of these so we can compile that. Yeah, that works perfectly. That's exactly what I was looking for. But that will allow us to compile with that code into this code. Oh, switch is like case. Switch uses case. Like switch, you can do cases. It's like an if else statement. So like it's like if you don't want to use, if you have a bunch of things you want to like a bunch of outcomes for one single thing, then switch is amazing for that. So like that would be technically that could be an enumeration of engine state instead of doing if or switch engine state. We could have, instead of doing equals, we would do that in the case. I'll pull up the book since I don't remember exactly what I'm doing with case and switch. I hardly ever use case and switch. They go hand in hand with enum though, because enum enumeration allows you to do object-oriented stuff, which I hate. So, actually, is the book in here? Yes. Which one is it? Oh. Oh, God. Flashbang. Let's look for what we're looking for, which is switch. Yeah, switch. Whoa. But yeah, it's like you have these if statements and all that. These are like pain. If then statements. Why would you need so many? Well, sometimes you do need some, like if it's like super specific cases, like or multiple things going on, maybe. But it's better to do the case and switch for readability, I think. Obviously, I don't use it very much, so I mean, who am I to say how good it is? What is this? Here we go. So if you have a switch for operator, this is how you would make it like a calculator that has one if statement, technically. Technically, it's basically just one if statement that checks, one big if statement that checks multiple different things. Like, for example, switch operator, then it checks case. If it's that, if it's that, if it's that, or if it's that. Now this could potentially be bad if you don't do it in the correct order. For example, I would say that with something like this, do it from the most common to the least common. And obviously, whatever your most common expectation is to the least common expectation is, and then have a default. So if it doesn't find any of those, boom. And the reason I would say that is because, for example, if you don't have an occurrence of something, it's just going to check each of the ones until it finds one occurrence or doesn't find any. You always need a default with a case, like a default case where it's like default something colon break, which would be a default, or something like that. Default. I mean, obviously there's going to be more to it. Like every case we can have, you can also have go-tos technically, from what I understand, but that's kind of messy programming and bad practice anyway. And every case will be in a break. So engine state should be like the first, the first thing that happens is we get the engine state from the import fish bitwise or fish. Yeah, what is it? Like fish.bitwise. And then we'll take the, and we also import, we'll be good to do that because it will just use the function from fish bitwise. We'll use segment bin. So the first case will be segment bin, which is just going to be used to check the state of the engine. So like, it's hard to think about this shit because like it's so abstract, kind of. It's kind of abstract. So the case would be 0x01, right? Like let's say we're looking for case and the value of engine state is 0x01. Or actually, technically engine state's not a byte or that. It's going to be a U-long to represent the engine state. And if it's not that, then it's going to do nothing. It's going to just break. What does 0x01 even represent? I don't know at this time, but I'm sure we'll figure that out in the future developments. We'll also import a write line function. Colon write ln. And then we'll just write a line before we do that. Make that a string as well. Boom. Yeah, so case is going to be 0x01, and then the default will be to write exception call it. Not even specify what it is. I don't even care, man. It doesn't even matter that much right now. It's just a basic starter point. So we're going to do a switch for engine.engine state. We'll also put this in a while loop. And if that breaks, then it will just break from the switch. No, actually, Set the while loop. So the while loop depends on... The reason it needs a while loop is so that way it keeps the engine up and running. So while... And that should be inside something Boolean or bool for alive. So there will be a alive which will be either true or false. Equals true. Well, engine.alive equals true. So that's how we will handle that. This is interesting, actually. I think I'm building some interesting code, but I don't really know what I'm doing. That's not how that works. This is gonna be an interesting project. I know for sure this will be an interesting project. Has to be, kind of. Then everything else should look good. Yeah, that's perfect. Right now the case here isn't completed. It's going to be a break again. But this one will throw the exception, and then it will change the engine state to false. So that would be the engine dot state needs to be false. Engine dot state equals false and semicolon. All right, and so from there, we now have to work on case 0x01, and that's going to be determined by getting the or engine alive equals false, which I mean I guess should be the state. And that's just going to check that every time it goes through. There's only two potential outcomes, true or false. That's pretty easy to do, I think. So now it has to go through these cases and switches. So that's how you create your basic, like, kind of program where it will drive itself, kind of like a car almost. That's why I'm calling it an engine. It just drives. This will just run forever in this while loop, and it will run a switch, which checks things. And if you can check things in a switch, well, that's the start of runtime, I think. I think that's the start of runtime. It's just a guy running forever, pretty much. So 0x01, we're gonna, before we do any of that, the switch will be not based on engine state, but it will be based on, or actually will be on, maybe it will be on engine state. But wouldn't it be on like current function or something like that? We can also create like threads and shit too, which we could use to handle different things. Have them also run. But that's going to get more complicated and more complicated. That'll be later down the line, I think. Just a lot to think about right now. We'll say that we want to grab the first 4 bytes of the number. So the number we know is 32. We've already seen with Fish Bitwise, where we compiled and ran these ones. It was like 31 and 28, I believe. Gives you that. So getting the first 4 numbers, we kind of have to define what that first 4 numbers means. That first half byte, what does that mean? So like, what do we want that to be, kind of? So I guess the type of instruction. So type would be a U byte type, or yeah, type equals the first first half bytes of the 32-bit number. Yes. And we'll say that it's going to determine like what the type is. And then these cases, there will only be 16 cases. So like, that's crazy to me. But yeah, there will only be 16 cases because or only 15. Well, actually, there will be 16 because the default case will just be the exception call, break the loop. These will go into cases and go into their own loop or loop switch cases. And then they'll have their own breaks from there, which will return it to the main loop. So it's just going to be a bunch of cases and switches and loops, essentially, with the get ubyte type, and then getting that and then performing actions off of that. So for now, let's go ahead and continue on with this. Oh, yeah. The ubyte for type is going to be equal to, what is it? Segment bit, right? Or segment binary with the values of 0x0, or no, actually, engine dot state and the other value, which is the starting or the number, or what was it, position and width, 24 to 4, so 24 with a width of 4. So like the start position and then width, yes. Position would be 28. Oh, 28 and 4. Gives you the first 4 numbers of a 32-bit number. And that's the return we need, or the statement we need. So that then creates our switch off of type. I feel like that's it is a variable I defined, so it's just registering it as a variable. Now we need to create cases for each of these. So that'd be, we can enumerate these different values to create the actual final output. As seen here, these are enumerated. Could be enumerated. So that would make things a lot easier to read. Let's scroll up until he does enumeration and just figure out some more stuff about that. Exceptions. Oh. Yeah, slash enumeration enum. Cool. This is the first instances of enum. Or actually, no. Hello, and then it can be... Oh, so enum... Hello. Oh, right here. This is perfect. So level can be a int, right? But then you can have it, the numbers be represented as low, medium, and high. So you would do an enum, that, and then boom. This way it's easier to represent what these are gonna be, technically. Enum type equal, or then you would do these, and that's where things get interesting. Yeah. You would do enum but that doesn't work because type is already defined. I'm using enum wrong again. So you would enum level. What are these? Int. Oh, you could enumerate those. Like my enum. But, kind of lost. Immutable variables, enumerated constants. So I guess you could use not magic. What the fuck? Converting from base type, that's just casting and stuff. Oh god. Alright, so here's enumerate. Unless we just knew what each of them does, but I don't want to have to memorize my own stuff. I want to write out a bunch of enums instead. Yeah. So you have that. Case 1, case 2, 3, 4, 5. Oh, okay. I would say put the case 2, 3, 5 first. I don't know. Where's enum? I don't think you can do that though. It has to go in order. Here we go. So this is a one where he's got an if operation equals that. Here's enumeration for operation, where he sets add equals 1, subtract equals so on and so forth. And so, I mean, like, I don't really know what types I'm going to have, but, I mean, I guess, obviously, there's going to be 16 different potential numbers to have. So, I mean, there's that. Like, I guess for now, we'll just create the basic ones, and then we'll figure it out later. Like, for example, we'll have... I mean, I guess execute is one? No. Like, we have components. Think of components, right? Like, we have... calculating, logical, stuff like that, like arithmetic equals 1. I think that works. There's gonna be so many problems with this code when we get... You know, I'm just gonna avoid compiling. Or not compiling. I'm gonna avoid enumeration for now, because I don't really know what I'm gonna put for those, and I don't want to have it cemented right now. So, But why would we have it check that first? I mean, engine state is separate from the actual code. I mean, this isn't really also a program that really does a lot. Paste. Like this is a program that you build another thing off of. Essentially. Like, you build an OS on this thing, which would be crazy, but you could do it. It's like the idea of it is that it runs and provides you the ability to do that. That should give me 16 total outcomes. And then we need another one to represent the other states. So obviously it will go 0x02, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, and F. Oh, E and F. Always forget E exists. Just such a useless number. Alright, so those are the cases. That's what the first can return. It can return up to 16 different potential outcomes for states that the machine can be in. And so now we have to figure out what to put in these. Obviously another while loop, which should be able to take the... Well, these will contain different functions, so each of these has a different purpose. For example, the first one could be like, I don't know, like memory handling, and then the second one could be something else, and the third one could be something... Like, these are going to be functions, or like different program codes, or like stuff like that. Instructions. Think of instructions like assembly. Yeah, that's where it's at. That's what we're going to do. So like for case 0x01, then we have 32 bits to work with too. Like, I've never had the opportunity to work with 32 bits before. That's crazy for like a machine like this. Like, this is effectively a machine, like almost like a simulated computer. So then we do a while loop with more switches. Then we check the next one. We could be like, however, there could be less cases for the next one. For example, case 0x01, we'll make this like memory stuff. Like, for now, these all just have return. So, I mean, I guess we'll just test compiling it. We'll give it a test compile before we do anything else. This is good, right? Okay, so ls try compiling fish 64, which isn't 64 anymore. I'm able to read the module Bitwise. Oh, right, I know what it is. And it also needs the fish Bitwise. Int. Oh, right. What are they? So, like, here we have int, apparently. Apparently that's the only issue so far. Trying to call it with int and int. So I guess it should just cast those straight away to the correct numbers. That's a bad idea. No, we should cast these ourselves. Can't really fix these. Oh, 28. 15 plus another... Bro, hex kills me inside. Hexadecimal, it actually is pain for me. Pain. Wait, that returns a U-long, doesn't it? No, it returns a U-int. Well, we're just gonna take a U-byte from it. Surely that won't break anything. Well, it won't, because they always allocate the numbers to the other side, right? I think they do. Should be fine. Engine state, which doesn't even have a number. Oh. I know what it was. uint state. And by default, the engine state is going to equal 0x or engine state. Yeah. And should just be the max for that. All of the... Oh god, how do you set it without using binary? Well, you have 32 bits, so you just do 0B 1000. That makes it easier to assign, right? Then you have 32. 000. For example, in this, we'll have 1. Binary is just easier for me to read, honestly, but hex, you know, I gotta get used to that. That should be 30. That's not 32. What am I saying? I was gonna say that should be 32. All right, now if we take half that, we have 4. Yes. That's painful to look at, but we can simplify this kind of. Each of these is just 0x 00. Instead, do get rid of this. Like 0x 01. And that'd be 64. 00 00 00 00. It's the default state for that. And engine.alive is true by default. But if it has no functions, it will just eventually be like, oops, not true anymore. Engine's not alive. Oh, I might have screwed up a little bit. Oops. Because it still has way too many of these. So that's a long, apparently. So that's what we're looking for? I mean, yeah, that actually does look about right. Wouldn't it just be a 1 in that position then? Since it's in the first half byte, that would be a half byte. I think that's how that works. Oh my god, bro, I gotta learn how to do this hexadecimal stuff. Cast U byte. Okay. Type int to U byte. Yeah, so it needs to be a uint. Oh, okay, cool. ./fish64. This is so cool. Oh, it didn't do anything. Just gave up. Where did it stop at, though? It's the real question right here. It just kind of gives up. Does it give up at main? I bet it gives up at main. Like, when it hits this first while loop, it's like... write ln... then do engine. And then boom. It might just get into the loop and break, so we'll see. So it's that number and true, which is the correct numbers. It's not hitting default. Write bin engine state. should be just that, although this needs to be capitalized. That will also help us out. Yeah, I got it correct. So now it hits this one and it just says return and then gives up on the rest of the function. Or actually, these should all be breaks. That's what it is. Return just means exit the loop at that point. However, what we should expect to see is that a white box will appear here with nothing going on. And that's what we want. Because then I can start building my machine off of this. The fish emulator right here. Fish simulator. Oh yeah, it's gonna be awesome. It's gonna be amazing. Should all be breaks now? Okay. Now that breaks from the loop, but also then continues to write and then continues to recheck the state. Should be, yes. Every time it does that, it checks the engine state. Then it enters the switch. And that's good. I'd prefer if this was not written every single time, but okay. Fair enough. So now let's go ahead and say that we need to create reading file or create some reading functions to pull out data from a file, because that's like the starting point. Like, what are we gonna do without something for the system to execute? Like, there's nothing for the system to do, right? Like, it has no information about what it's supposed to do. So then, like, what is it supposed to do? It needs to pull information from somewhere. Obviously, that means the first line of a program built for the system must have that. So engine state would be loaded from a file read of that, which is going to come from standard.file potentially. So if we go to the folder where that's at, that's not what we're looking for. DTools. What did I call this again? Bro, I forgot the name of this. Alright, fish common. Alright, and then, that first thing is to pull it. That tells it what to do. So create an empty file. Actually, call it instruction dot or example dot bin. Oh, get this shit out of here. And technically it can't read byline, since if it reads byline, it will not do what it needs to do. It needs to be serialized into a actual integer, which means we'll have to probably set things using stuff. Octeta, give me that. Yes, open. Alright, so the first thing it's gonna expect is a 0. Yeah, it expects, no, 0, 1. What? Is this, excuse me, this is hexadecimal? Expects 0, 1. 0, 0, 0, 0, 0, 0. Wait, what the hell? 1, 0, 0, 1, or 0, 0, 0, 0. First thing it will read is this. Then the next thing... Next thing to read is... Okay. So I can fit 4 instructions per line, looks like. Yeah, it looks like I can fit 4 instructions on each line. That is pretty good. Yes, that first one, state is going to be initialized always as a 0x00 or that number, which I mean, technically, we don't even need to have engine state be like that. I mean, engine state will change. Do we need to transfer engine state from the file to that? Well, actually, we can define it. If it starts off as 0x0 as 100, 0000, then yeah, that's perfect. Now that means that every time we go from a case, like if there's lower cases, well, I mean, I guess every line should just start with that. But technically, oh, well, that doesn't necessarily have to start with that, because it has an engine state called .alive. So the property .alive just means, or that variable, that Boolean variable will just be like, yeah, the engine's running. It's okay. And then if it hits this, it'll be an exception. Essentially. That's the idea. Then the rest can be anything. These can be that. However, that first one has to be 0, 1. And then the second one can be, like, you could technically have 1, 2. Or like 1, 3. Or I believe 1F. Doesn't have to be caps. Or caps. 1F. Oh, I mean, oh, apparently caps will just make it a fun. Oh, so I'm just writing what am I doing? Why is it doing that? I am lost now, 1, 0. So it has to be like 1, 1. That'll give us the first one of 1. If it's 1, 0, it should also break from a case. So essentially, each of these loops needs to get a mini loop that reads the next one. So let's go ahead and create the next one, which is going to be... Let's say that this tells it to read, if it gets case 1, read the next 4, and then write a line. Just to model it out, kind of how it works. 28, it was like 27. So like you would read 4, or no, you would start at 2, 4, and you would go 4 to get to 28. So that then reads instruction from there. Technically, these could be stored in the struct up here. Although, I wouldn't want to reinitialize those. And I have plans to save that struct as a state. So, like, you can reinitialize the state of the program from that struct. It's an idea I got from somebody who made a video game using D. Although, what the problem is with this is that it initializes inside of a while loop. And then we'll have it write the bin for instruction. All right, so that should be ready to compile and test. And as you can see, it is doing that. So it reads the next 4, and if it gets if it gets zeros, then that will create the case for the next one. So it has to have another switch for the instruction. And each of these can have their own separate instructions, so it's like a hierarchy almost. Instruction hierarchy. Which gives you a lot of potential for different instructions, theoretically. Oh my god. Now we have to have another case that looks like this. I can hear that thunderstorm coming. It's going to do amazing things. And then put this inside of this switch. And then tab all of that. Oh my god. Now ideally, from here, instead of doing just reading the instruction, we would then delegate threads for these things, but I don't know exactly how I would go about doing that yet, and I don't really want to think super hard about it right now. I really don't want to start thinking about that right away. It's gonna melt my brain. So that can get lowered down. That can get tabbed and indented, and this can become a 0x01. Man, of 32 bits, you could create a lot of instructions. There's like a lot of potential with this. Even if I just take it half byte by half byte. So if this one is gives you an F, for example, 15, or essentially if we had 16 there, so like 1F would be what we're gonna go for. That will give us the 15th one, which will be to do something. Or yeah. So let's go ahead and get that started then. For example, we'll say that the engine state is, well actually, this is terrible, I think. I don't think this is going to work well. Because, I mean, look how big that is. That is a lot of lines. And in theory, I mean, well, those two, like that 8-bit that byte can tell it to be like, those 8 bits can tell it a lot of stuff. I mean, honestly, you can do a lot with those 8 bytes. I think like you could be like, all right, first we're going to go ahead and go to this, and then we're going to do that. Like, kind of, something like that. But then it's kind of really extrapolating what it's supposed to do now from that. Like, what is the program going to do next? Well, let's just say we want to set the bit of the next instruction to, or it'll take 2 numbers, add them together, or no, because you don't use numbers, you use registers. It makes it really easy. But we don't have registers. This is a bad idea. Why are we making this? I mean, the concept's pretty cool, but like, I don't know what to do next with this. This is kind of where I'm at now. Kind of lost now. Like, what would you do next if such a thing? Like, yeah, we can read the first one and like we can keep going down until it's nothing. But what's the point of that? We already have this. I mean, I guess if you're making a game based off this, like an NES game, like almost. Seems case doesn't. Well, case would work perfectly, but like, why would I even make this? Like, how do I make this further? Because, like, yes, we can create instruction sets, but we don't have registers or anything like that. Unless we create registers inside of our engine. That would be the way to do it. Have registers in here. And have that be an array. And that's the registers. We can have as many registers as we want. Holy crap. Now we're talking. How many do I want? So like, let's say I want 16 or something like that. Bro, this is, now we're thinking computer brain. For now, we'll just give it, we'll say it has something like that. And then, we could give it like an L3 cache or some shit like that. You just gotta think on the side of components. We're basically building making a component into a program at this point. We'll have 8 registers. I've decided this time we'll have 8 registers, and it will all equal 0 from the start. And then we'll have RAM. Which will be also a value, probably like 32 uint of RAM. Oh my god, guys. I have 32 uint of RAM. What the fuck is this shit? It's coming down to this. And then you just need ways to combine 8. Like, if you have, let's say, for example, I have register 1 and 2, right? You should be able to combine those and perform functions on them. Well, you can do that using bitwise operators. So the first case would be to load a register with a number. So, for example, if our instruction is 0x100000, and this one is 1, then I think we should just then say that 0x01 is loading registers, or putting memory into the register at that specific one. So for example, you could also do, so 0x01, this is to specify which register it needs. So we could have up to 16 registers instead of having 8. Let's go up for 16. Why not? I mean, you don't really need that many. Or actually do 8 so we can then have wipe registers as well. And wipe each specific register, or wipe all of the registers. So yeah, we'll just create that, and then we'll have engine.register of index case, or no, instruction. That would be a bad idea, to have it engine.registers of index instruction, which is that. Actually, you could do that technically if you use just one in there. That would work way more efficiently than writing 1,000 cases. However, you still need to have it would work. I can get rid of this switch. We don't need it. We don't need to have a switch here. It's completely unnecessary. It's cool, but like it's not needed. Because you can do engine.registers and set engine.registers of instruction. And then have it load the next well, we still will need a switch, but it will be for something else. Oh, I realize. So technically, the first, like for example, if we take a line, for example, like right, this is a massive. You can have this be very long, like that. Look at this, very long. But what essentially this is basically just first instruction, number, number, and number. Like first instruction, second instruction, number, number. Or first instruction, data, number, number, something like that, kind of. Or like instruction, function, data, data. Like instead of doing it like that, we serialize it and do it like one line. First thing you find on the line is an instruction, which then specifies what to do next. Yo. And then, yeah, so that would be a way of doing it as well. So that would mean we've only used the first two of the instruction. And then we have that. So now we can use these two. Well, this is how assembly usually works in binary. So am I just creating a binary emulator at this point? Like, what am I doing with my time? But yes, you'd take that. That could be more specifics of it. So the next two will be the case. So we'll have to create another. Like, I like this idea, so we're going to save that for later. But, and then you can use the instruction to determine which register to write it to, since there's only going to be really 8 potential outcomes or so. Well, we'll figure that out in a second. We're going to do a uint. We're going to create another uint for instruction equals segment bin and not engine state of those. We'll copy that, paste that in there. Rename this from instruction to instruction. What do we call this even? I mean, I guess a specifier, identifier. Well, there actually is a name for them. They're in like the headers on binary. It's like a dot or no assembly. They're in headers. It's like a dot something, dot another thing. I don't know what the names are for those properties. I guess the first one is the property. The second one is the instruction. So first you have a type, then property, then we get down to the instruction. So you have your property of your type of your. I mean, type is usually used for like variables. I don't want to rename it though. This is pain. Because I mean, yes, there's proper vernacular, and we're just not using it. I don't know what the proper vernacular is for assembly because I'm not a assembly person. I am a high-level programmer. I don't stoop to those lows, bro. Although I definitely am starting to slowly turn into some kind of psychopath, becoming a assembly programmer or something like this. And then we're gonna do instead of doing 24, bro. If you did 24 to 8, that would be for the RAM and shit. We're gonna do 4 less than 24 is 20. And then it goes up, finds 24, goes up. It's like in Fish Bitwise, when we did the 24 to 4, that gets you 24, and then also that. 27. Wait, doesn't that grab the number in front of it? This could be pretty bad if it doesn't work, but we're gonna then do return. So return will essentially break the program. Don't do that. That will cause issues. Return will get us out of both the loop and the other thing. Instead of doing the break function there, doing a return breaks the entire thing, so it will stop the entire execution. As you can see, now it has RAM. Well, memory and has RAM, but they're not initialized for anything yet, so they're just nothing. Very good, but it's pulling zeros, and that's not what we want. So the first state should be to load that initial, hook that initial register, which is to grab these. Because otherwise, if it just pulls zeros and zeros, that's not good. So the first one, like literally the default case for this, if it pulls no zeros, right, and it gets into that second right here, first thing it's going to do is go, or actually, wouldn't the default just be that it has no zeros in there? Well, I mean, unless you specify that's 0, 1, I mean, the default is already 0, 1, right? It's already that. State's already that. So then, this is why software development takes so long, because you have to think about it for like 50 years before you actually do anything. But yeah, it does both of the tasks. And obviously you don't want it to just create its own, like, oh, the program now needs to create this number. That's not what we want it to do. Oh my gosh. Oh, what? I thought you were like, my bad. I thought you were like, what is this, man? And I was like, I thought you were like, oh man, this guy must be crazy. He's doing some crazy shit. Both the images look pretty similar. Yeah. I was like, yeah. Man, I was so lost in the program for a second too. No, that's my bad. Oh my gosh. Yeah, well, we need to do a switch in a case, I think. Or something. For something else. For another thing. And another thing. And another thing. And, so we have our uint for property, which is that, equals that, and that. Okay. So if it doesn't really find anything, if that's the first thing it does, 0x01, the default should be to pull the first line of code to run the... Yeah, the default should be to pull the first line. Like, it should be defaulting to something like that. I don't really know. My brain's fried right now. I think I've worked too hard on this program so far. But we have made more progress than more lines of code, guys. I mean, look at all these lines of code. I mean, so much progress. But I think its default function should be like pull the next line of code if it doesn't find anything on that one. Write bin property, write bin instruction. Like eventually I'll have just that moment where it just comes to my brain. I'll be like, oh, interesting. Actually, yeah, we should make a case. Case, and we'll call it, like, the case will be for the actual property. Or switch for property. That's the correct answer to this problem. Switch for property. Boom, boom. We got to write bins for instruction, all that. And then, so if it doesn't find anything, it needs to pull from a file and load up the registers with what it needs to do. Example. Auto file equals, actually, I actually don't know how to pull a raw file into the program and take a line from it. I guess you would use data serialization to do this. And then you would use compilers to make the files it uses. So, case 0x01, boom. That's the first case. And then it will have a default. Is just to return. And in 0x01, the first, well, the default will be to attempt to load, or no, load the registers. So it will attempt to load registers from the bin. So yeah, the first one we can have up to, I guess engine state, we could have all of these on the outside. We don't need to reinitialize, well, we do need to reinitialize them in the while loop. Just like these, they'll just be inside of these tinier ones. But I mean, I guess we could put them out here. And theoretically, I mean, that would make it much easier. And then it just needs to, I think that would work better to put them out here, and then another uint for the current copy that, paste it right here. We want that to be, oh wait, these could use 8. You could use 8 for instruction and 8 for the... Right, because that's... You could technically have 3 different instructions on one different one? Hold on. So yeah, that's the first one. Second one was instruction, and the third one. So you have your state and property, instruction, instruction, instruction. Or instruction and register, or instruction and values. Technically, it'd be better to do instruction and values in one. However, if you want to work with 32 bits, you need to extend that because you need to use the next set as the instruction. So, I mean, the next instructions will just be specific to each one. Like, you could still handle longer numbers, right? We can still handle those, but it'd be easiest to use, yeah, I think I understand what I'm thinking of. I just really can't explain it well. Technically, this could be just type. Boom. Okay, I think that's the cleanest I can get that to be. Since I don't want to really initialize those a whole bunch, since the less you can initialize, the better. The faster you'll run as your code goes. Yeah, code goes vroom vroom like a car, bro. Good starting point. And then, obviously here is where we start working with those 16-bit numbers. So first it takes those and gets us these instructions. This one will put two numbers in. It will load numbers from the registers. For example, the registers can hold 32 bits, but it could just take a byte and load it in for this case. Like, for example, this could just set the engine, or, well, technically the register is those other two values. For example, we already have the first two instructions. 30 and 30 here are not instructions. These are going to be values in this case. So this will be I guess a short load 16 is what we'll call that for now, temporarily. So yeah, load, yeah, so it will just say that the we need to now create set bit functions for like the entirety of the set an array of bits. So that's fun. Instead of return, it will just break. So yeah, let's go back to fish Bitwise. We need to create another one called set segment. uint set or just set segments equals, or no, not equals. I'm thinking of variables for some reason. uint input. I'm pretty sure it's gonna be the same, but we'll have to figure out how to do this part because I have no clue. Well, let's go to the drawing board first and figure out what we can do from there. What we could do, because I'm pretty sure you just mask it usually. Always it's mask. When in doubt, mask it out. All right, so we have the number 1 0 1 0 0 0 1 0 0 0 0 0. We want to set all of the numbers here. You could invert those. You could, but we want to set them all. Right? This is that one part of the. Technically, that's load 8, by the way, not load 16. But load 8 doesn't use the registers, it just puts it straight in the instruction itself. So the load 8 instruction is fascinating. It's going to be a fascinating one. Oh, yeah. I already like this. We already have to start writing documentation for it. But yeah, those will be the 8-bit operations. Then we'll have 16-bit ones and all the other shit too. I don't know why I'm going in depth with this drawing, but let's say these are all zeros, right? This is the end of my other number. We want to load those, right? And we want to not care about any of these others. So first, we're going to shift it this way and set everything to zeros. Then we're going to go this way and leave these zeros. Then we're going to change these zeros at the same time. So we need to invert those zeros, but by a number. So we need to XOR them. So that way that would be the way I would do it. So go this way, go that way, and then get XOR'd at the end. I feel like that's a funny way of doing it. All right. We'll now see how AI would go about doing this. Now that I've at least put some thought into it. How to set. Oops. How to set bits. Use the OR operator with a left shift and mask. Set bits at position 3 to 1. Clear bit force to 0. Which we already did that one. Toggle a bit, flip to... Yeah, use XOR. Set multiple bits to a specific value. Create a mask. Shift. So yeah, like the other ones, you create a mask for the... Bro, this is like, what's it called? Where you like fucking... Oh, C++ where you operator overload. So we got our position, width, and new value. Those are all going to go in the function. Oh. Byte injection tools is kind of what it is. So yeah, let's just copy these. Position, width, new value. I think segment bin is bad. Get bin is better. Oh, yeah, it's definitely better. And then, next task. After we get the bin, or create the set bin and get bin, we need to add another uint for value? Uint, I guess, for value. Yeah, to change them to. Now let's go ahead and do what it says. So first you create a mask, and then you and it. Oh, and you can technically do a U-byte. I'll just do that. Well, no, we might want to put multiple in there. No, let's keep it as a uint. Actually, I think it might only work with a U-byte. Let's go U-byte. Yeah, that's the way to go. Then it wants to create a uint mask, which equals, what was it exactly? Something like this. equals cast u byte with an inverse of all of that, which is a shift from position and width. Kind of complicated, but yeah, I have no idea what that's doing. I'm gonna be honest, that is complicated as hell. But that should be fine. Invert couple of these parameters. Minus something. Was it like -1? Oh, it's not even minus, it's just a mask from... Actually, that's just width, right? So like, width going this way, shift by width that way. Or no, that's position. And then we need another shift from width. Or shift from width to 1. And then also subtract a -1 from this and put that in parameters. I think that's exactly what it has. We need to double check that because I want to make sure it's right. Yeah, so that's making a weird bunch of fucking shifts. That's like operator overload. It's like almost what that is like. Except not really, because operator overloading is just fucking bullshit anyway. And it doesn't exist in D-Lang, so that's good. Don't need to make a uint. We need to mask and equals. And that's to take mask, or value and equals mask. So like our input will do that, because that's how I do my input and equals mask, semicolon. So value uint mask equals. Parameters never used, where? That's good. That's good. That's it? What's the problem here? Suspicious parameter is never used. Cast U byte. I have the 3, right? No, something's wrong with this. Yeah. So the first one is that. So 1 to width. That's good. This is good. And this is good. So what then is causing that issue? It's the real question. Well, it's never used or something? But then it gets used here. It's like, what is the issue with that? Primary expression required, or something like that. For now, we'll just close that. So that means that I don't know what's wrong with it, but something is wrong with that. Oh, casts. Oh, you know what it is? It's cast. That's what it is. Yeah, that just happens sometimes. That's just how it be sometimes. Alright, then we need to go ahead and shift it. Oh, that's actually not that hard. Shift and or. So you just shift it and you... Oh. What is it? He said input in that one. But I'm going to take an output probably. I guess you could return input and just do what he's doing. like we use input instead of value. We could technically just return input. Although in the past it's worked better to uint output equals, or pipe equal, or hold on. That doesn't work because it needs to be input pipe equals, or basically or equals, and then go from there with the whole new value shift by position. Value shifts position in that direct position to the left. All right, so that's how that's gonna work, and then return input. And now we need to test it, because that's how things do be going. That's the testing, ready to go. So, oh, you know what I did? Position. Technically, this is now get bin set bin and technically you just go 24 and then you do comma 0x0 or 0b0, my bad, 1 0 or 1. Let's go 1001, so that way we know what it is. So that's binary formatting for the bin. Remove this, remove that. All right, that should be a good testing function. It should be good to test. Although there was something wrong with it. Position. /fish bitwise. That works as intended, surprisingly. All right, so now let's go back to here and fix all the shit we broke by changing things because I wasn't satisfied with them. So first of all, segment bin has become set bin. So no longer is there going to be segment bin inside of my engine. It's going to be set bin. Paste. Paste. Then, okay, those are good. Bro, that 32 units of RAM is going to be insane, guys. It's going to be spectaculoso. 32 units is insane. You know how, you guys know how big the uint is. It's 32 bits of RAM right there. 32 bits of RAM. Absolutely amazing. Technically, you could increase it. I mean, in theory, we could just do an array of arrays. Technically, that's an associative array because if you were to switch this for int, it'd be the same as saying, well, although it is not two different types, this is still a number, and you're defining the indexes. So that technically could be considered an associative array, just by how it kind of is. I mean, I think I really can't explain how that would work really well, but I mean, I can try. uint 32. Then, okay. Let's continue. We should be good, as long as nothing else is broken. I don't think anything else is. Oh, these were supposed to be get bin. Get. And also, you can't compile it while it's in this state, so this needs to not be like that. Property. Bro, property? Oh my god, you can tell I'm tired. Fish 64. Are we gonna do it with fish 64? Yes, because it's 32. Something doesn't seem right. Something tells me that this isn't correct. Something tells me that's a little bit wrong. You know what I mean? Like that's not supposed to be that number. Oh wait, that's the right bin for type. Oops. And then paste. We need to write the actual engine dot state to see what that is. Engine dot state. Nice. So the first thing it does is goes, all right, let's go ahead and read this. Boom, shifts it all the way down here. Reads it. Then there's nothing else for it to read because it doesn't have any other things. So in 0x01, which is the case that we're in, or the default is to break, and I mean the default should be to load up memory, but now we can select. So the default will be to set those other two to that number. Before the program exits, I want to also get an engine.state, so that way it'll make debugging really easy. Because when the engine is not alive, it exits the loop, writes engine.state down here. That'll tell me exactly what's wrong with the machine, and we'll be able to figure out from there what to do. So that it will be like super easy and really nice, you know? So default will be to set, this allows me to test it inside of the default for this one. So then we can do 0x0, default is to set bin for the original numbers to, let's see, goes 24, 20, so then we have, after that, we have a lot of space. So we have 2. Subtract from that. What is that? So like, here we have 28 to 32. Here's 24 to the next number. Here's 20 to the next number. Then there's going to be another one, but that doesn't matter. So that would be 16 to the next number. So these ones are going to be 16-bit stuff. Or actually, instead of property, we just call this size. Engine state, type, size, instruction. So the size just says, oh, we're handling 8-bit numbers. For example, in the first one, we're going to handle... Oh, wait, oh yeah, that works. Yeah, type, size, and instruction. Which can technically start earlier and give you more outcomes. So we could start from 16 in this case, or have it be that full first number and then have a shit ton of possibilities. Or, oh my god, man, there's a lot to think of with this. For now, we'll just have that. And then if later on we want to extend the potential for more functions and shit, yes, we can do that later. These first ones will just be loading registers with data. Alright, so the first one is gonna be to... Oh, that is the case for 0x01. This is really confusing. We'll call this / 8-bit. Values. Value sizes. Just one instruction. For now, yeah. But with the larger ones, you get more instructions, but then it has to be more specific. It has to be like, you have to load the registers with those. Like, you could technically build the register with like with other shit. Oh my god. Be like, you could technically you could have to build the 32-bit register using the 8-bit functions and just reiterate those over and over again. And then I mean, like, there's a lot of options with this, I feel like, to proceed forward, like have different instructions for those things. But for now, just continue with this. Set bin takes something like this. So we just copy that from there. So 24, 27, 0. We're going to just test it out to set the... And technically, this will just start at 16. 16 and goes up by 8. Then we have... two more that are going to be... Like, you get more instructions with this, though, too. That's interesting. Alright, so then you can go and do... What would that leave us with? So that gives us from that there... Okay, so we have 8 bits here and 8 bits here. 0 to 8 and 8 to... Well, 0 to 7 and 8 to 15. Right? That'd be 0 to 7, 8, 15. That wouldn't be 8 bits, would it? That'd be 0 to 7, 8. What the? I mean, we technically have 2 bytes there. I mean, 2 bytes to handle. I mean, Well, no. In the first one... Wait, why is there only 3 here? Oh, here's what we're looking at. Okay, here we go. So that's our instruction. Here's our 2 things. Technically in assembly, you would be like instruction, or you'd be like value, and where to put the values at is an instruction. I mean, that's like the most efficient way to do it. That's ARM assembly, though. Oh, I should definitely learn to write more assembly code. I mean, writing my own assembly is... my own bytecode assembly is gonna be fun. That's my brain in the background. It's a fucking black hole right now. So we have input from 0, and then... Why does it say 24 to 27? I mean, it's position and width. Basically the same thing. I guess it is position width. I mean, position's 2, width is 3. Okay, well, anyway. Let's ignore that. We're gonna go ahead and take this. We're gonna make it 4 or 8, and we'll do from 0 to 8, and then we'll have another one 8, 8. Do I have an assembly book? Yeah. It's ARM assembly. It's there's a guide. It's like a tutorial thing, like for basics. And then we'll have this one be just a string of 1s. And instead of using input, we're gonna go ahead and take the engine.state. That's going to be what we're going to take. We're going to paste engine.state in there. And then we're going to load it with these 2 numbers. For now, just to test out what that does. Right. Did I specify size somewhere else? Oh. Alright. And what the hell do we have here? So, what happened is 0 to 8 looks to have not done anything. Technically it's 0 to 7, 0 to 8. And this one writes the bit of engine state. So, let's get that engine state actually. Inside of here. Which did something different. Two and 1. I'm like lost right now with this. Oh, yeah, it's not writable like that. Well, we'll just have to figure it out. I mean, it loads 3, so that we're not looking at these ones, but then on this one, it says it wants to do it there. Doesn't. And then the last one, that's the last one. Oh yeah, it's pain o'clock. Wait, did I get it backwards? Position width, right? Yeah, position width are the same, are not the same thing. 1, 7, 8, and then the width should be 8. Something different happened. It's not really inserting them, is it? Or no, it does it the other way around. It's like if I want to place it at the 24th value. Well, that just shifted the... Oh, wait, you can't change engine state from outside because you have to... Can you change engine state from outside? You cannot do that. That's not a thing. It would have to be like a global, wouldn't it? You'd have to make a new engine with the engine state. Well, we can pull engine state for a line. I wouldn't... Oh, wait, these aren't doing anything. That's what it is. Alright, well, engine... or engine dot state equals that. Same thing here. Yeah, that should do. Now it works. Let's see that it worked correctly and not that it did some dumb shit. So in the first one, it takes 1 and defaults, or reads 1 down here. Doesn't read any other numbers in those first 3. And then it defaults to the addition of those, which that starts at 1. It should be 0 to 7. Read D and D that. That's about what it should be like. Although that should start a number lower as well. That's 4. And we want to put those in at... Oh, wait a second. Why is there a bunch of zeros between them? Position 8? Oh, right. That means that we could theoretically have 8 positions there. Ah, that's why. So, yeah. And that just adds that in there on top of everything else. But if you look at engine state, it lost that first bit. So now it no longer knows what it is. It's just a 0, which returns break anyway. And that's not what we want. And this also doesn't have a right ln, or does it? Yes, it does. Okay, so that's a great example of how it can't or can kind of work, or it's a good starting point. But I think I'm going to end today's episode here because my brain is like about to explode probably. So I'd like to thank you all for watching. I will see you all next time, and hopefully my brain doesn't blow up in the next 10 minutes. Goodbye. I'll work on this more today, and I'll kind of flesh out my ideas for how I'm going to make fish runtime work. But hopefully it'll be amazing. See you all next time, and goodbye.